All right, Algebra 2 students, this is Mr. Morris's lesson. We're going to review. I hope you guys are staying safe and trusting in Jesus and the Lord during these uncertain times. When the winds and the waves are blowing, that's when we need to fix our eyes, okay? So let your mind be resting in that truth, on that truth. But we're going to go ahead and just get straight to it. Just a quick recap of what we were discussing before spring break, before all the world basically shut down. All right, we were talking about the different aspects of a quadratic function and how to identify the characteristics. This representation here is a quadratic representation or quadratic graph. It's quadratic, remember. We talked about how to factor those on the previous test, and we just are now talking about the way that the graphs tend to look. They make this U-shaped graph, and there's different features. One of the things we discussed was the fact that the zeros go by several different names. You can call them x-intercepts, which kind of are practical because that's where the graph will intercept the x-axis. You can call them the solutions, you can call them roots or zeros, but these all mean the same thing. So a lot of times you might take the ACT test, or you could be taking one of my tests or a standardized test, something in the future. They might throw one of these terms out. It's the exact same question, all right? Another thing we talked about was something called the axis of symmetry. I'm leaving it as AOS because you should have the notes on that. The axis of symmetry is an imaginary line that just bisects the middle of this parabola, and it's where it would cross the x-axis. So the axis of symmetry, if you look right here, I'll try to zoom that in. Can you see that? Crosses right at -2. So if I'm answering this question, if I'm asking you to tell me what these different features are, you'd have to tell me, well, it crosses right there at -2. While we're at it, the zeros, what would they be? Well, where's the graph touching the x-axis? Looks like it's touching it. Bingo, right there at -2 as well. And so remember, quadratic, there are always two solutions. So you'll learn about this more in future videos or in class. But when it touches a point, comes right back up, that means there are two solutions, and they're both at -2. All right. So quadratics have two solutions. So just know that. All right. Max or min, we talked about this in class, guys. If it's a max, it would be an upside down parabola, but since it's going this direction, the bottom of your vertex is below, so that's clearly a min. Okay, I'm going to circle these so that you can see them a little easier, all right? And then the last component is the vertex, which is this bottom point of a parabola or the upper point, depending on which shape it is. But right here is that tip where it bends and goes the other direction. And that's the actual ordered pair, okay? It's not just -2, it's -2, 0, because it doesn't go up or down. So I need an x and a y when I'm talking about the vertex. So this would be -2 for the x. It doesn't go up or down. It's really right there on the axis, so I have to leave it this way, okay? So that's just a quick recap of kind of what we were getting into that last week before spring break. So hopefully that is helpful and beneficial to you. Here's what I want to go over with you guys today, and then we're gonna kind of mush. We're not gonna mush, okay? So don't worry about that. But we're gonna kind of push our way into how to algebraically solve quadratics, coming up with zeros and solutions, roots, using algebraic processes, okay? But that's not today. Today, I want to talk about how to find the axis of symmetry and the vertex when you have a quadratic function that's written in what's called standard form. Now remember, we were just talking about a different form of a quadratic, which is called vertex form. I'm going to write that. You're going to have to forgive me. This is as good as my handwriting can get, all right? This is called vertex form, what I'm about to write. And remember, that basic presentation was y equals a x minus h squared plus k. And if you remember from class, we talked about how vertex form is kind of called vertex form because you can easily see the vertex just by looking at the form. All right, if you had and I'm just making this one up, but let's say you had a real problem, we'll make that 2x minus 3 squared plus 1, all right? Let's say you had a quadratic function look like this. This is clearly in vertex form. It just lays out just like this parent example. Remember, it's the opposite. I think I said this in class. When it's inside parentheses, you got to think the opposite. I like to look at this like jail. Why are you in jail? Usually because you do the opposite of what you should be doing in society. So if it says x minus 3, remember the x, when you look at the vertex, is going to be the opposite sign. So it's going to be a positive 3 when you look at that. And then it'll be a positive 1. So 3, 1 would be the vertex. All right, and I'll just write that out there. There it is. I'm singing it for Matthew because I know he likes Pikachu. Likes voices like that. All right. All right. So moving on here, this is a different type of function. It's not in vertex form. This is called standard form, where it's nice and easy. You got the A, the B, and the C, just like we've been studying over the past few weeks. But what do we do when they ask us for the axis of symmetry? But you don't see the axis of symmetry or the vertex or anything like that just by looking at this format. You don't see it. I don't see it. So that's why it's good, and you need to write this in your notes, people. This is the axis of symmetry formula, and that is really bad handwriting, so let me just tell you what it says. It says negative b over 2a. When I used to work at a different school, inner city school, we used to say negative b over 2a, and everyone liked to say a. But anyway, negative b over 2a is the formula. This is the axis of symmetry formula. Why do you need to know that to find the vertex? Well, the axis of symmetry is an x amount, right? And it always matches the x of your vertex. So if you can get the axis of symmetry, you'll figure out what part of the vertex is, okay? You see that? Look at this video. Y'all need to rewind it back and listen to what I just said again because it's so important. All right, the x of the axis of symmetry, it gives you an x value. It matches the x of the vertex, you see? So this is going to be very helpful right here, okay? That means right here. So you got an A, a B, and a C. Mr. Morris, what is the A? Well, look at that. Even though you don't see it, it's a negative 1. That's a negative 1. The B would be 8. The C, 16. But do you see a C in this formula? Tyler, do you see a C in this formula? Matthew, do you see a C in this formula? LA, do you see a C in this formula? I don't think so, Mr. Morris. I didn't think so either. So don't even worry about it. The good thing about the AOS, the axis of symmetry, that only requires the knowledge of what the A and the B is. You feel me? All right. So let's go back here, and we're going to plug in this formula and figure out what the AOS is. So negative B. Well, the B is what? It's 8, Mr. Morris. Man, you guys are really good students on video when I can't really hear your voices, and I just have to make believe that you're paying attention. All right. So negative B, okay, is the formula, look at that, negative b, over 2a. And the a is, don't get it confused here, that's a negative 1. So I got to make sure I get my signs right. That's where y'all are going to get in trouble if you're not paying attention. All right, negative b over 2a, negative b over 2a. All right, we're just going to work that out. Negative 8, 2 times negative 1 is negative 2. And anytime you got a negative over negative, it equals a positive. So boom, that's my axis of symmetry. If you were to graph this, put it in a calculator, like a graphing calculator, it would give you a parabola, but that imaginary line that goes through would actually cross. Where is it going to cross? Oh, at 4, Mr. Morris. So you know the axis of symmetry to this particular parabola, boom, it's going to go right through 4 on the x-axis because our formula told me so. Now, you might be wondering, I know you're wondering this, so let me just go ahead and tell you. Mr. Morris, I was just thinking, now that I know what the axis of symmetry formula is, I'm just curious what, I don't know, the vertex might be. Well, that's a great question, little Susie. Too bad you're not in this class. But Matthew, Ellie, Tyler, you listen, all right? You need to understand that now that we got the axis of symmetry, I just said earlier that the axis of symmetry will always be the x of the vertex. So we know our vertex, as far as the x is concerned, is positive 4. We just have to figure out what that y is. Gee, I don't know how to do that. Are you sure? Because it says right here that y equals negative x squared plus 8x. You know what the x is? It's 4. See that? So since you know that the x is 4, don't tell me you can't use that to figure out what y is. Oh, Mr. Morris, it's starting to make sense. I thought it would, kid. So let's listen together. So you got y equals negative x. Well, we know what x is. X is 4. So we're going to do negative 4. But make sure, you listening? Make sure you put parentheses around that, okay? Because you're going to raise it to the power of 2 according to the problem, the function. You plug that in, I'm going to do another parentheses 4 because there's another x right there, 8x. You know, we're just plugging it in. Plus 16. I just plugged it in right like that. All right, so no pressure on me, but I got to do this math in my head. You got negative 4 squared, all right? Well, that's, last time I checked, 16. You got to add whatever 8 times 4 is, which should be 32. And then you got to add an additional 16 to that, all right? So all I did is I raised that to the power of 2, got 16, did the multiplication, that's 32. It says 16 there, I brought it down, all right? That's essentially 32 plus 16, I believe is 48. You add another 16 to 48, help me out, but is that not 64? Is it not 64? So that's not my answer, this is my answer. What's the vertex? It's both an x and a y. So I gotta put that in there right there, all right? That's how you find the vertex. All right, so I'm gonna keep it real simple today. This video should help inform you, and you should watch it several times, people, because you can find the zeros, which are the same thing as the x-intercept, solutions, and roots, simply by looking at where the graph hits the x-axis. You can also tell me the axis of symmetry, because it's gonna be that part in the middle where it touches the x-axis right there. Just so happens it's the same as a 0. Not all the time will it be that way. All right, max or min, well, it's at the bottom, so we got to go with the min. What's the vertex? What's the ordered pair right there? That's negative 2. Ooh, you go up or down? Nope, you just stay right there, negative 2 comma 0. You got me? All right. So now we got the vertex form. We talked about that last week. We got a, parentheses, x minus h, parentheses, squared plus k, all right? This h and k, boom, 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 right there. That's where you're getting the info to get the vertex when it's in vertex form. Vertex form is called vertex form because you can see the vertex in the form, okay? Keep it simple, Ellie. Keep it simple, all right? Right here, it is not in vertex form. This is called standard form. You cannot just eyeball that and figure out that 464 was the vertex. I mean, come on. That doesn't even, no, ain't gonna happen. Okay, so we had to utilize this formula that some very brilliant people came up with and let us know about to figure out what the axis of symmetry is to this problem, which happened to be, when we used the formula, positive 4. We took positive 4, we plugged it back into the y, excuse me, I'm tripping, plugged it into the x of the standard form, and take a look there, there we go. So you can figure out what the vertex is when it's in standard form when given the axis of symmetry formula. You use it, you figure out the x, you plug the x in, you figure out the y, and you move on to bigger and better things. Okay? So this is our video for today. This is serving as a recap of what we've discussed, and I'll be posting the homework on my Facebook page. Okay? Hope this was helpful. This is for Algebra 2. Mr. Morris. Everyone stay safe. God bless you.